Welcome to St.SEBASTIAN PU College. Namaste student. Today I am going to explain chapter 3 Classification of Elements and Periodic Properties. Now in this slide I am going to explain historical development of a periodic table. Before explaining history of a periodic table, I will ask one question. Why was the need for the periodic table? Why was the need for the periodic table? Now, by 1865, about 63 elements were known. It was realized that instead of studying the properties of all the elements individually, instead of studying the properties of all the elements individually, it would be more convenient if it is divided them into groups or families such that each group contains a number of elements with the similar properties. Okay, so with the help of periodic table, it is easy to, scientists thought that it is easy to study the properties of elements. It is easy to study the properties of elements. Now I am explaining the historical development of the periodic table. So the development of periodic table began with German chemist John Debiner. John Debiner, who observed that several of three closely related elements, which he called triads. Which he called triads. Now, what is the meaning of triads? Triads means it is nothing but a set of three elements. It is nothing but a set of three elements. He arranged elements. He arranged three elements, a set of three elements. Now, how he arranged? Now, in triad, the middle element had an atomic weight almost the arithmetical mean of the other two elements. Now here a format have given A, B, C. Imagine that A is one element, B is another element, C is one more element. Now how he arranged in the form of triad? Now A, B, C, three elements. So that's why it is called as a set of three elements. Now how he arranged? Based on the principle called as middle element had an atomic weight. It is almost the arithmetical mean of the other two elements. That means while calculating, if you want to calculate atomic weight of B, so that is always equal to arithmetical mean of A plus C divided by 2. Atomic weight of A plus C divided by 2. This is a principle behind John Debiner periodic table triads. So I will repeat it again. So development of a periodic table begin with the which scientist? Scientist called as a German chemist called as a John Debiner. He observed several of three closely related elements. He named as triads. Triads means a set of three elements. Now how he arranged these three elements? That is, in triad, middle element's atomic weight, it is almost equal to arithmetical mean of the other two elements. Arithmetical mean of the other two elements. I will show you a few examples. Now he is the Debiner. How he arranged? See, lithium, sodium and potassium. Atomic mass. Now he arranged the element based on the atomic weight or atomic mass. Lithium atomic mass is 7. Potassium atomic mass is 39. If you take the atomic weight, if you want to take the atomic weight of sodium, now what you will do? Now I made a mistake in this. That is, I made a mistake in this. Just check. If you want to calculate atomic weight of sodium, how you have to calculate? 7 plus 39 divided by 2, that you will get as a 23 as a answer. Okay, so here I made a mistake. It is not a 23. You have to write 7 plus 39 divided by 2. You will get as a 23. Okay, so atomic weight of sodium can be calculated with the help of arithmetical mean of lithium and potassium. Okay, now you can see the set of other 3 elements like calcium, strontium and barium. Here you can see. Okay, now if you want to calculate atomic weight of strontium, you will get as a, if you by doing arithmetical mean of calcium and barium, that is 40 plus 137 divided by 2, you will get as a 88. Okay, almost nearer value you will get. Either it is exact 88 or you will get as a nearest value of 88. Same way chlorine, bromine, iodine. Okay, say bromine, atomic weight of bromine is equal to atomic weight of chlorine plus atomic weight of iodine divided by 2. Okay, so you will get the answer as a 80. Okay, nearest value you will get as a 80. Okay, now the same other concept, other triads. Okay, he prepared 4 set of elements, in the sense 4 types of elements. Okay, you can see here Debiner triads. Okay, now next, so what is the merits, what is the success of this triads? Now classification is done on the basis of atomic weight. At least scientists tried the arrangement of elements based on the atomic weight. This is the first step of the preparation of the periodic table. So this is one of the success. At least scientists tried the arrangement of elements based on the atomic weight. Okay, so next, demerits. Now here demerits, not all the elements could be fit into triads. Okay, newly discovered elements could not fit into the triads, like iron, magnesium, nickel, cobalt, zinc and copper are similar elements but could not be placed in the triads. And newly discovered elements did not fit into triads, and very dissimilar elements. Okay, dissimilar elements, the properties of elements are dissimilar, still it is fitted into the triads, but it was a wrong concept. So based on that, Debiner triads were discarded. So the next scientist came John A.R. Newland. He prepared the periodic table based on law of octaves. Now, what is the meaning of octaves? Octaves means, here it is given a law of octaves. What is the principle of law of octaves? Atomic weight of 8th element starting from a given 1 is a kind of repetition of the first, like 8th note of an octave in a music. Now musical note, you can see here Indian musical note, sa re ga ma pa da ni sa. This is a 7 musical note. Okay, based on the musical note we are comparing the elements. How we compared? Now when the elements are arranged in increasing order of their atomic masses, when elements are arranged in the increasing order of atomic masses, again he also used the principle of arranging based on the atomic masses. Even Debiner also arranged the elements based on the atomic mass only. Okay, even Newland also, he also arranged the elements based on the atomic weight or atomic masses. Okay, now what he told in the law of octaves, when the elements are arranged in increasing order of their atomic masses, the properties of 8th element are the similar to that of the first. Okay, now you can see the picture of Newland here. Now how he arranged, you just see here. Now based on the musical note, sa re ga ma pa da ni sa, that is a musical note. Okay, based on the Indian concept. Now the hydrogen is the first element. Now hydrogen is the first element, lithium is the second element, third beryllium, boron fourth, fifth carbon, nitrogen is the sixth, seventh one is a oxygen, and F8th. Okay, so hydrogen and fluorine, properties of hydrogen and fluorine is almost similar. Same way, if I start lithium as a number 1, okay, lithium 1, beryllium 2, boron 1. If I start with the lithium, so lithium 1, so for lithium I will give 1, 2, 3, 4, 5, 6, 7, 8. So 8th element is a sodium, first element is a lithium, 8th element is a sodium. So properties of lithium and sodium is almost similar. Same way, if I consider beryllium as a first element, so count. Okay, beryllium is a first element, 1, 2, 3, 4, 5, 6, 7, 8. 8th element comes as a magnesium. Okay, if I consider beryllium is a first element, magnesium comes as a 8th element. So properties of beryllium first element is almost similar to the property of a 8th element, that is a magnesium. Same way you can compare it with the boron and aluminum, carbon and silicon, nitrogen and phosphorus, oxygen and sulfur. Same way lithium, sodium, potassium. Okay, it gives the similar elements. So based on his point of view, what he told, when the elements are arranged in increasing order of their atomic masses or atomic weight, the properties of 8th element are similar to the first element. ಎಂಟನೇ 8th ಎಲಿಮೆಂಟಿನ ಪ್ರಾಪರ್ಟಿ ಯಾವುದಕ್ಕೆ ಈಕ್ವಲ್ ಆಗಿರ್ತದೆ? ಫಸ್ಟ್ ಎಲಿಮೆಂಟಿನ ಪ್ರಾಪರ್ಟಿಗೆ ಈಕ್ವಲ್ ಆಗಿರ್ತದೆ. ಸೊ ದ್ಯಾಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಅ ಲಾ ಆಫ್ ಆಕ್ಟೇವ್. ಆಕ್ಟೇವ್ ಮೀನ್ಸ್ ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಅ ಮ್ಯೂಸಿಕಲ್ ನೋಟ್. 7 notes are there, sarigama, padani, sa. Okay, so based on that concept he arranged, so that's why it is called as a law of octaves. Now what is the merits? He introduced the concept of periodicity. Now what is the meaning of periodicity? Periodicity means what he told, that is the first element property is almost equal to the 8th element. So that means periodicity means it is properties of elements are similar after certain intervals, after certain gap properties of elements are similar. So this is called as a periodicity. So he introduced the concept of periodicity. Okay, but that time a name was not given as a periodicity, but at least he introduced the concept of periodicity. So this is the success of the Newland's periodic table. Demerits. Now what is the demerits? After discovery of noble gas, now actually Newland periodic table, it was suitable only for the lighter elements, but after discovery of noble gas, heavier elements, it was completely failed. Okay, so you can see the picture of the Newland's periodic table. Okay, now here how it is arranged, you can see the colorful picture of the Newland periodic table. Now the next scientist came as Dimitri Mendeleev. Okay, Dimitri Mendeleev. Now his law is called as a Mendeleev's periodic law. Now according to his point of view, what he told, the physical and chemical properties of the elements are a periodic function of their atomic weight. Again he also arranged the elements based on the increasing order of atomic weight. The first scientist, German scientist called as John Debiner, he's also explained the atomic mass of the element. And the second scientist called as Newland, he also explained the arrangement of elements based on the atomic mass. Okay, and Mendeleev also explained the arrangement of elements based on the atomic mass or atomic weight. So according to his point of view, Mendeleev periodic law, what it says, the physical and chemical properties of elements are a periodic function of their atomic weights. Now how he arranged, you can see the arrangement. He arranged the known element in vertical columns. Vertical columns are called as a group, and horizontal rows are called as periods. Okay, now you can see the arrangement, how he arranged the Mendeleev's periodic table. You can see. Okay, now periods are there, and columns, vertical columns are called as a group. Okay, group number 1, 2, 3, 4, 5, 6, 7 mentioned in the form of Roman numbers. Okay, that is called as a group. Okay, and group, first group and second group, third group. Group is also divided into subgroups like it is A and B. Okay, so here it is, you can see A and B subgroups are present. These are called as groups. Vertical columns are called as a group, and horizontal rows like this, okay, are called as periods. Okay, now this is a arrangement here. So how we arranged increasing order of atomic mass. Now, what is the merits or what is the success of the Mendeleev's periodic law? Now here all 63 elements were arranged. Okay, that time 63 elements were discovered. So all the 63 elements were arranged in a Mendeleev's periodic table. And periodic properties are directly proportional to atomic weight or atomic mass. That means how he arranged the elements. He arranged the elements based on the increasing order of the order of the atomic masses or atomic weight of the elements. Okay, so and then he gave or kept a gap for undiscovered elements. Okay, now here you can see this, that is gap is kept. Okay, gap is kept for the undiscovered elements. Now here you can see this gap. Here also it is 72. Here also kept the gap. Okay, so gaps are kept for the undiscovered elements. Okay, after discovery of the elements, so that scientists can fill the elements to base in that gap. So that is a main success of the periodic table. Okay, and then after that the next merit, that is properties of undiscovered elements were predicted. Okay, and properties also he explained. Okay, properties of the undiscovered elements were predicted or already explained. So that is the so because of this reason his table was very famous. Okay, so why? What is the reason for the famous for the Mendeleev's periodic table? The reason is main thing is gaps were kept. Gaps for undiscovered elements. Gaps were kept for the undiscovered elements, and side by side he already explained or predicted the properties of undiscovered elements. Now, so what is a reason for the failure or demerits? So grouping of the dissimilar elements. Okay, now example, sodium, potassium, rubidium are grouped with the copper and silver. Now here you can see. Okay, now here lithium, sodium. Okay, in this group number 1, lithium, sodium, potassium. Okay, rubidium, cesium. Now in the subgroup A, under the group number 1, even copper is also placed. Okay, copper and silver is also placed. Aurum is also placed. Okay, dissimilar properties. Now property of lithium, sodium, potassium are entirely different from the properties of copper and silver, aurum. But still he grouped under a same group number 1. So this is one failure of the his periodic table. Okay, now next what is next failure? Separation of similar elements. Separation of similar elements like platinum and aurum. Au means aurum. Okay, that is a gold. Now you can watch it here properly. Now aurum, here you can see aurum, okay, and then even silver also. Now it is separated, okay, it is separated, but still its properties are same, okay, properties are similar. So he kept in a similar way, group, okay. Now the next one, discovery of isotopes. Now isotopes definition I already explained in the previous videos, so but still I will explain. What is the meaning of isotopes? Isotopes means that is atoms of the same element. So you can see the example I have already given, hydrogens, atoms of the same element having, that is a different atomic mass, that is 1 2 3, but a different same atomic number as a 1, okay, different atomic mass and same atomic number. So atomic mass is a different 1 2 3, okay. So discovery of isotopes. Now what happened here, actually in the group, now for hydrogen only one place is given, okay. After discovery of isotopes, actually there is no place to keep hydrogen which is having a atomic mass 2, and there is no place to keep hydrogen of atomic mass 3, because only one place is allotted for a hydrogen atom, okay. So this was the failure of the Mendeleev's periodic table. So the next one, it is atomic weight of cobalt is greater than nickel, okay. So here in the how he arranged, actually the concept was what he told, according to his Mendeleev's periodic law, how he arranged the elements based on the increasing order of atomic masses. Elements are arranged based on the increasing order of atomic masses. So based on this concept, actually nickel should be kept first, okay. Actually nickel should be kept first, then it is a cobalt, okay. But what he did, he placed the cobalt first and nickel next, okay. But according to his point of view, how he arranged the periodic table, I mean elements are arranged based on the increasing order of atomic masses. So but here cobalt atomic mass is more compared to nickel. So nickel supposed to kept first, then it is a cobalt, okay. Next, it is a position of hydrogen. Position of hydrogen is also, it was a question mark. He could not explain what is a position of hydrogen. So because of this reason, it was discarded. Mendeleev's periodic table, it was discarded, okay. But why his periodic table is very famous? That is he kept gaps for undiscovered element, and he also predicted the properties of undiscovered element. This was a reason why his table was very famous. The next, it is Henry Mosley. He explained the modern periodic law, okay. Now he explained the periodic properties of the periodic table based on the increasing order of the atomic number. That means to say, the physical modern periodic law, it says the physical and chemical properties of the elements are periodic functions of their atomic numbers. Now he introduced a new concept as called as atomic numbers. Till from John Debiner up to Mendeleev's, they explain the arrangement of elements based on the atomic weight or atomic mass. But Henry Mosley, he explained the concept of atomic numbers. Okay. Now after doing several experiments, he proved that physical and chemical properties of the elements which is present in the periodic table are the periodic functions of their atomic numbers. That means elements are arranged based on the increasing order of the atomic numbers, not a increasing order of atomic mass or atomic weight. So this is a new concept explained by Henry Mosley. Now, so modern periodic table, in the modern periodic table, elements are arranged in the order of increasing atomic number, okay, in a manner that the elements with the similar properties fall in the same vertical column. While elements are arranged in the increasing order of atomic number, while doing like arrangement, what happened? Elements with the similar properties fall under same vertical column. Okay, so you can see the modern periodic table. Okay, so here 18 groups. Okay, there are 18 groups, that is a vertical column are called as a groups. Okay, so in a modern periodic table, so how many groups are present? 18 groups are present. Vertical columns are called as a groups. Okay, 18 groups are present, and horizontal rows are called as a periods. So 7 periods are present. So you can watch the modern periodic table, how it is arranged. Okay. Now, so this was the modern periodic table. Next, the concept is periodicity. Now, periodicity I already explained while explaining the Debiner concept of a periodic table. Now, what is the meaning of periodicity? Periodicity means it is nothing but a recurrence of similar properties or repetition of similar properties of elements after certain regular intervals, when they are arranged in the increasing order of the atomic numbers. Okay, properties are similar properties will repeated. Similar properties will be repeated after certain intervals or fixed intervals when they when the elements are arranged in an increasing order of atomic numbers. So this is called as a periodicity. So this is very important. Question is very important. Usually it is asked for 2 marks. What is periodicity and what is the cause of periodicity, or what is the reason for a periodicity? I hope you understood the concept of periodicity. I will repeat again. It is nothing but a repetition of the similar properties. Properties of the elements will be repeated. Okay, ಯಾವಾಗ ರಿಪೀಟ್ ಆಗ್ತದೆ? ಆಫ್ಟರ್ ಸರ್ಟನ್ ಫಿಕ್ಸ್ಡ್ ಇಂಟರ್ವಲ್ಸ್. ಒಂದು ಸರ್ಟನ್ ಗ್ಯಾಪ್ ಆದ ಮೇಲೆ ಎಲಿಮೆಂಟಿದ್ದು ಪ್ರಾಪರ್ಟಿ ರಿಪೀಟ್ ಆಗ್ತದೆ. ಅದು ಹೇಗೆ ರಿಪೀಟ್ ಆಗೋದು? ವೈಲ್ ಇಫ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಅರೇಂಜ್ಡ್ ಇನ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಆರ್ಡರ್ ಆಫ್ ಅಟಮಿಕ್ ನಂಬರ್ಸ್. ಒಂದು ವೇಳೆ ಎಲಿಮೆಂಟ್ಸನ್ನು ಇನ್ಕ್ರೀಸಿಂಗ್ ಆರ್ಡರ್ ಆಫ್ ಅಟಮಿಕ್ ನಂಬರ್ಸ್ ಮೇಲೆ ಅರೇಂಜ್ ಮಾಡಿದರೆ ಆಗ ಏನಾಗ್ತದೆ? ಕೆಲವು ಎಲಿಮೆಂಟ್ಸಿದ್ದು ಪ್ರಾಪರ್ಟೀಸ್ ರಿಪೀಟ್ ಆಗ್ತದೆ ಆಫ್ಟರ್ ಸರ್ಟನ್ ಗ್ಯಾಪ್. Okay, so I will repeat it again. What is a periodicity? It is nothing but a repetition or recurrence of similar properties of elements after certain regular intervals when they are arranged in the order of increasing atomic number. So this is called as a periodicity. Okay, now here, what is the reason for the periodicity, or what is the cause of periodicity? Now, the periodicity will exist due to the reoccurrence of the similar electronic configuration at a certain regular intervals. Recurrence of a similar electronic configuration at a certain regular intervals. That means if you watch the periodic table, see the first group. Okay, lithium, sodium, potassium. You can write electronic configuration. Lithium atomic number is 3. What is electronic configuration? 1s2, 2s1. Sodium atomic number is 11. Electronic configuration is 1s2, 2s2, 2p6, 3s1. Please write it in your rough book while explaining. Okay, write by yourself. Lithium atomic number is 3. So electronic configuration is 1s2, 2s1. Sodium is 11, atomic number 11. So electronic configuration is 1s2, 2s2, 2p6, 3s1. So potassium, what is you will get up to 4s1. So what happened if you come down from lithium to sodium, potassium? So outermost shell has 2s1, 3s1, 4s1, 5s1, 6s1. So it is a repetition of electronic configuration. Only the number it will changes, but S1, S1, S1 remains the same. So it is nothing but a repetition of similar electronic configuration. So this is the reason for the periodicity. This is the reason for the periodicity. Okay. Now, how it is classified? Periodic table. Now, classification of periodic table. Classification of periodic table, it is based on periods, that is a horizontal rows. I already told periodic table. Modern periodic table contains 7 period, okay, and 18 group. Period means it is nothing but a horizontal rows. Now, first period, it is called as a very short period and contains only 2 elements. So here you can watch it. Okay, first period, that is like this it will come. First period, second, third, fourth, fifth, sixth, seventh. Okay, this is a continuation of 6th and 7th period. Okay, so total 7 horizontal rows are present, so that is called as periods. So 7 periods are present. So first period, it is a very short period. Okay, it contains only 2 elements, that is called as a hydrogen and helium. Hydrogen and helium. Second and third period. Second and third period. Okay, so second and third period, it contains, see, you can see here, second and third, it is a short period. It contains 8 elements. So in the first period it contains 2. Okay, second period, second and third period, it contains 8 elements. Okay, then fourth and fifth here. Fourth and fifth, it is a 18 elements. 18 elements are present. Okay, so first period it contains only 2, so that's why it is called as a very short period. Second and third, it contains 8 elements, so it is called as a short period. Fourth and fifth, it contains 18 elements, so it is called as a long period. Okay, so sixth period. Now see here, from here, after this continuation, it is from lanthanide series, you can see here. Okay, so sixth period, it is a very long period. It contains 32 elements. Okay, and seventh period, it is a incomplete period. Seventh period is called as a incomplete period. So I will repeat it again. First period, it's a very short period, contains 2 elements. Second and third, it is called as a short period, contains 8 elements. Fourth and fifth, it's a long period, contains 18 elements. Sixth period, it is called as a very long period, contains 32 elements. And seventh period is an incomplete period. So this is a classification of periodic table based on the periods. Next, classification of elements into blocks. Now here you can see, this is the skeleton structure of the periodic table, modern periodic table. Now, so how many blocks are present? There are 4 blocks: S block, P block, D block and F block. Now here, this is a S block. Okay, this is a P block. So this is a D block. And this is a F block. So this is S block, P block, D block, and this is a F block. Now here also it is given S block. It is called as a S blocks are alkali metals and alkaline earth metals. S blocks are alkali metals and alkaline earth metals. Okay. P block contains non-metals, and even it contains halogens, and even it contains noble gases. Okay, D block, it contains transition metals. Transition metals means the properties of elements are intermediate between metal and non-metal. Okay, properties of D block elements are intermediate between metal and non-metals. It shows metal properties as well as non-metal properties. And F block, it is a rare earth metals. And F block almost elements are that is a man-made elements. Okay, man discovered elements, man-made elements, and radioactive elements. Now one by one we'll study about the blocks. S block. So here the first two groups are called as S block elements. You can see here. Okay, first two groups are called as a S block elements. This entire concept. Okay, now what is the meaning of S block elements? Last electron or valence electron. So here see lithium. Okay, lithium, sodium, potassium, rubidium, cesium, francium. Okay, that is comes under group number 1, alkali metals. Group number 2, it is a alkaline earth metals. Now here last electron or valence electron enter into the s orbital of a valence shell. Last electron or valence electron. So what is the meaning of this? Now see here below I have written the electronic configuration of lithium. Lithium atomic number is 3. So what is the electronic configuration? 1s2 2s1. Okay, so last electron is this. That is a electron which is present in a 2s1. That is called as a last electron, or called as a valence electron. What is the meaning of valence electron? Valence electron means it is nothing but a last electron which is present in the outermost shell. So which is the outermost shell? Number 2, it is a outermost shell. Okay, so here last electron enter into the outermost shell. So that is called as a valence electron. So valence electron enter into the s orbital. Okay, last electron or valence electron enter into the s orbital of the valence shell are called as a s block elements. Okay, now you can write electronic configuration of other elements of group number 1. Lithium, sodium have written here. That is 1s2, 2s2, 2p6, 3s1. Here also it is enter into the last electron enter into the valence shell, s orbital of the valence shell. Okay, if I want to write potassium as a 19, you will get last electron, it is a 4s1. Rubidium, it is a 5s1. Okay, so here what happens, we can see lithium outermost shell is 2s, 1 electron is entered to the s orbital. Sodium outermost shell is 3, so here electron is entered into the 3s1. Potassium 19 atomic number, outermost shell is a 4th shell, electron enter into the s orbital of the 4th shell. Rubidium, it is a electron, last electron enter into the s orbital of the 5th shell. Okay, so this is called as a s block element. Same way you can write it for a second group number 2. Now here the first element, it is a beryllium. Now if you want to write electronic configuration of beryllium atomic number is 4. Okay, so it is 1s2, 2s2. So magnesium atomic number is 12. So 1s2, 2s2, 2p6, 3s2. So if you want to write the calcium, what is electronic configuration you will get after last outermost shell is a 4s2. Same way strontium. Okay, so it will come like that only, as 2s2, 3s2, 4s2, 5s2, 6s2, 7s2. Okay, that means so s block elements here also last electron enter into the which orbital? S orbital. Okay, S orbital, here also S orbital of the outermost shell. So this is called as a S block elements. So I will repeat it again. That is a valence electron or a last electron enter into the s orbital. Okay, s orbital of the outermost shell are called as a s block elements. So based on that you can write a general electronic configuration of s block elements. Now how we can write the general electronic configuration? Here you can see that is a noble gas configuration, or you can write directly as a ns1 to 2. ns1 to 2. Okay, now N is 1 for group number 1. In the second group, how many electrons are filled to the outermost shell? 2 electrons. So that's why group number 1 and group number 2 belongs to S block elements. So it is written as N as a 1 to 2. Okay, I hope you understood the concept of this. Now here, why I have written as a noble gas NS1 to 2. Here I have written as noble gas NS1 to 2. Now here, see in the case of lithium, now atomic number is 3. Okay, now here I have written as 1s2, 2s1. Now 1s2 means 2 electrons are present. Now helium, it contains 2 electrons. So helium is a noble gas. Okay, so based on that, it is written as a noble gas 2s1, like that, or I can write ns1 since it is a group number 1. Same thing, even you can write it for a sodium up to 1s2, 2s, 2p6. How many electrons are over? That is a 10. So 10 means it is nothing but atomic number of neon is a noble gas. So noble gas, neon is a noble gas, so noble gas N3s1, or generally I can write noble gas NS1. So this is a configuration of general configuration of sodium. Okay, so same way even I can write it for a group number 2 also, group 2. So noble, so that's why it is written as noble gas NS1 to 2. I hope you understood the concept of S block elements. Now next it is a P block elements. Now here P block elements, what I told the definition of S block elements, it is nothing but a last electron or valence electron enter into which orbital? If it is a S block, so of course it has to enter into a S orbital of the valence shell. Okay, now here P block elements, what is the definition? Last electron or valence electron enter into the P orbital of the valence shell. P orbital of the valence shell. So general electronic configuration. Now that is group number 13 to 18. Group number 13 to 18 belongs to P block elements. Group number 13 to 18. 18 is a noble gas elements. So group number 13 to 18 belongs to P block elements. So here the few examples have given. Boron, atomic number is 5. So it is written as 1s2, 2s2, 2p1. Neon, okay, so boron. Now boron, it is written here 1s2, 2s2, 2p1. So if you want to write for carbon, so atomic number 6, of course it becomes 1s2, 2s2, 2p2. Okay, and nitrogen atomic number 7, so 1s2, 2s2, 2p3. Okay, so oxygen 1s2, 2s2, 2p4. Fluorine 1s2, atomic number 9, 1s2, 2s2, 2p5. Neon 10, 1s2, 2s2, 2p6. Okay, so what happened? The electron is filled. Okay, now up to 6. Then aluminum, it is nothing but atomic number is 13. So it is 1s2, 2s2, 2p6, 3s2, 3p1. So it is 10, 12, 13. Okay, so like this it will come. Silicon 14, so it becomes a 3s2, 3p2. Like that it will go up to argon, it becomes 3s2, 3p6. So what is the outermost shell in this? Okay, now based on the electronic configuration, what is the outermost shell? Now here boron, I will draw the atomic atom of boron. Okay, so usually how we will draw boron? It has a nucleus and first shell and then second shell. So based on the configuration, boron, first shell, how many electrons are present? That is 2 electrons, so 1s2. Okay, now second shell, how many electrons are present? Total 3 electrons are present in the second shell of the boron. So that is written as in the form of 2s2, 2p1. So this is called as a second shell. So which one is outermost shell? Outermost shell is called as a 2. outermost shell is a 2. Even in the case of neon, outermost shell is a 2. Okay, so based on that, what is electronic configuration we supposed to write? That is nothing but a NS NS to NP1 to 6, NP1 to 6. Okay, that is 2s2 completely filled. So based on that, NS2. But NP, that is 2p1, 2p2, 2p3, 2p4 up to 2p6, neon up to 2p6. So based on that concept, it is NP1 to 6. Same concept is even aluminum, from aluminum to argon, 3s2, 3p1 to 6. So gallium 4s2, 4p1 to 6. Indium 5s2, 5p1 to 6. Okay, titanium 6s2, 6p1 to 6, like that it will go. So based on that, general electronic configuration of p block elements, it is written as NS2 NP1 to 6, or more clearly we can write as noble gas NS2 NP6. Now next, d block elements. Now of course here the last electron enter into the d orbital of the penultimate shell. Now what is the meaning of penultimate shell? It is written as second from the outermost shell. Second from the outermost shell. Now here you can watch it as d block elements. It is started from scandium. Atomic number is 21. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, so you can see that red, with the red marker it is marked d block elements. Okay, so scandium electronic configuration is written here: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Now what is the meaning of penultimate shell? Okay, now in this configuration only, you can if I want to write it in the form of structure. Okay, so how many shells are present in scandium? That is, this is a nucleus. First shell. So first shell, how many electrons are present? 1s2. Second shell. So how in a second shell, how many electrons are present? That is 2s2, 2p6. This is a third shell. Okay. In a third shell, 3s2, 3p6, 3d1 is also present. Okay. I will write it again so you can understand more clearly. Now I will just show. It is a scandium. Okay, so nucleus. Now first shell, it contains 1s2, 2 electrons are present in the first shell. Second shell, 2s2, 2p6. In the third shell, okay, third shell, it is based on the electronic configuration, 3s2, 3p6 and 3d1. Okay, 4s2 is there. So fourth shell contains 4s2. This is the electronic configuration of scandium. 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. Actually electronic configuration how you should write: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then 3d1, because energy level of 4s is less compared to 3d. It is proved with the help of n plus l rule. Okay. N plus L rule. If you don't know, watch the previous video of N plus L rule. In that I explained how the 4s energy level is less compared to 3D. Okay. So here, based on this, which one is outermost shell? That is a shell number is 4 is the outermost shell. Okay. So which one is the second outermost shell? That is a third shell. Third shell is the second outermost shell. Okay, so I hope you understood the concept. Outermost shell is a fourth shell, second outermost shell is a third shell. Okay, so based on this concept, now here what is explanation is given: last electron enter into the d orbital of the penultimate shell. Now in this concept, which one is the outermost shell? Outermost shell is a fourth shell. Okay, 4s2. So second outermost shell is a third shell. Okay, so third shell. Now d block, if I want to say as a d block element, there should be a d orbital. Okay, so here it is a d orbital. What is a d orbital is present in which shell? That is in the third shell. So that's why it is called as a penultimate shell. That is a second from the outermost shell. Outermost shell is a fourth one. So second outermost shell is a third shell. Okay. So based on the concept, how it is written, general electronic configuration. So outermost shell, it is written in the form of NS. Okay, so NS2, that is 4s2. So what is a second outermost shell? That is a 3. Okay, outermost shell is a fourth, and it is a third is 3 is a second outermost shell. So for the outermost shell, I have written as a letter as a N. Okay, N. So if I want to write it for 3, how I can write? If N is equal to 4, so if I write N minus 1, it becomes 3. That means 4 minus 1, it is called as a 3. So based on the concept, I will rewrite. Outermost shell, it is a, okay, so outermost shell is a 4. Okay, second outermost shell is a 3. So 3, it is written like, it is in the form of N minus 1. That means 4 minus 1, it becomes 3. So 3 is written in the form of N minus 1. So N minus 1 with respect to which concept? That is a 3D. Okay, 3D. So I will write the general electronic configuration, that is NS2, that is 4s2. Now 3D, how you should write? 3D, it is N minus 1, that is 4 minus 1, you will get answer as a 3. Okay, so that is with respect to d orbital. So d orbital, how many electron is filled in the case of scandium? Scandium, it is only 1 electron is filled here. Okay, scandium, only 1 electron is filled here. Here only 1 electron is filled. So based on that concept, outermost electron is Ns2. Okay, so 3D. 3, if I want to write 3, so I will write in the form of N minus 1, that is 4 minus 1, it becomes 3. 3D. Okay, so D. Now D, how many electrons are filled? In scandium, only 1. Okay, same thing if I write titanium, it becomes 3D 2, vanadium 3D 3, and then chromium 3D 4, like that it will go. Okay, so based on that, general electronic configuration is N minus 1 D 1 to 10. What is the maximum capacity of capacity to fill the d orbital? It is only 10. Okay, 10 electron I can fill in the d orbital. So based on that concept, I can write the general electronic configuration for d block element is N minus 1 D 1 to 10. Next one is a F block elements. F block elements. Now here, last electron enter into the F orbital of the antipenultimate shell. Antipenultimate means it is a third from the outermost shell. Okay. That is first shell, second shell, third shell, fourth shell. If it is a fifth shell, okay. This is outermost shell. This is a penultimate shell. This is a antipenultimate shell. So third from the outermost shell. Anyway, details of F block elements you are going to study in a 12th class. So here a general electronic configuration of F block elements is written in the form of N minus 2 F 1 to 14, N minus 1 D 0 to 1 NS 2. Okay. I will give a homework as a write electronic configuration of first element of F block. First element of F block, that is, here it is cesium 58. Okay, this is a homework for you. Write electronic configuration of F block elements. First element of F block elements, that is a cerium, atomic number is 58. So here you can see how it is divided, classified based on the block. S block, P block, okay, S block, P block, This is T block and this is a F block. I hope you understood the concept. Thank you.